In this example, we're going to find the average value of the function f of x, which is the square root of 3x plus 10 on the interval from -2 to 2. So here's our interval from a to b, and we want to find the average value of it. So we're going to just set up our own regular integral from -2 to 2 of the square root. Well, we're going to be taking the antiderivative. Let's just rewrite that so that it's easier. We have 3x plus 10 all raised to the 1/2 power. Instead of writing the square root, we'll just write it as 1/2 since they are the same thing. And we're going to put a dx in here. So this regular integral would tell us area of the function, but we want average value. The difference between area and average value is we need a 1 over b minus a. So for this one, we're doing 1 over 2 minus a -2, which is really going to end up being 1/4. That makes sense because we're dividing by the number of numbers, and there are 4 numbers between -2 and 2. So we're going to divide by 4, multiply by 1/4 is the same thing. So looking at this integral, we're going to end up with a 1/4 out front. And if we think about integrating this, we have the integral of 3x plus 10 to the 1/2, which is kind of complicated. It would be a chain rule if we were taking the derivative of it, which means it's going to be u sub for the antiderivative. So I'm going to have to think about how would I use u sub for this. So u is what's being manipulated. It's 3x plus 10. Again, I know it's a u sub because it would be chain rule for the derivative. The other way of thinking about it is if it was just x to the 1/2 or x under the square root, it would not be a u sub. But if it's just x plus 1 to the 1/2 or under the square root, it would be u sub. So anything more than x to a power, we're going to use u sub. Just like with derivatives, anything more than x raised to a power, we used the chain rule. So we want to take the derivative of 3x plus 10. The derivative of 3x is 3. The derivative of 10 is 0. And then we're going to multiply by dx to get du by itself. So now we have our u and our du. We have bounds at our x values, so we need to change those into u values. We want to figure out what is u when x is -2 and what is u when x is +2. So we're going to plug in to the function that relates our x to our u's. So here, u is 3x plus 10. So for this one, we have -6 plus 10. 10 minus 6 is 4. And my upper bound, 3 times my x is 2 plus 10 gives us 16. So doing our substitution, we're taking the integral from 4 to 16 in terms of u. This whole thing is u to the 1/2. And then I just want to make sure I have a perfect du so that I can do my integration. So I would need a 3 and a dx. I'm looking at what's left over when I sub in for u to the 1/2. And I don't have a 3. All I have is the dx. So what I have is 1/3 of my du. Or the visual way of doing it is I need a 3 in here. A 3 dx is what I'll sub in for du, but I can't just make it 3 times too big. I need to balance it out with a 1/3 outside. So either way, we get the same thing. We have a 1/3 on the outside and a du on the inside. I'm going to multiply those fractions together at the beginning. 1 times 1 is 1. 4 times 3 is 12, so we have 1/12 outside. And now I'm ready to integrate. I might have to do some side work. I need to do 1/2 plus 1. So 1/2 plus 1 is plus 2/2. That gives me 3/2. So I'd have 1 over 3/2, u to the 3/2. And then we want to remember to flip our complex fraction. So when we do this integration, 1/2 plus 1 is 3/2. And instead of writing 1 over 3/2, that's very confusing. We're just going to flip it. 1 divided by 3 over 2 flips to just be 2 over 3. We're not going to use a plus k. We're going to use an evaluation bar for this problem. We're going to evaluate from 4 to 16. I could multiply those fractions together out front again, just to make it less fractions to plug into my calculator. I have 1 times 2 is 2 in the top, and 12 times 3 in the bottom is 36. So I have 2 over 36 out front, or 1/18 is the same thing if you want to use your calculator to do that. That's probably the fraction it would give you as the reduced version is 1/18. Either way, it's fine. And we're going to plug in our upper bound, 16 to the 3/2, minus our lower bound, 4 to the 3/2. And so we are going to get 3.1 repeating. Just using our calculator. You could also leave that as a fraction if you would like. It doesn't matter. So what we want to remember here is that we already applied the average value formula. We said right from the beginning we have a 1/4 out front. All we did is we ended up multiplying it with the 1/3, and that gave us 1/12. So we've already applied the average value formula once. We don't want to accidentally divide by 4 again. We've already done that. So just be careful that you remember to divide by the number of numbers. So in this case, divide by 4, multiply by 1/4, but you don't want to do it twice. So we've already accounted for it, and we just did U sub and found average value.